Six goes further to ask us. The diagram below, not drawn to scale, shows two cylindrical water tanks, A and B. Tank B has a base diameter of 8 and a height of 5. Both tanks are filled with water. Calculate the volume in tank B. Now volume is equal to cross-sectional area times height. Now the cross-sectional area is pi r square. Pi r square. Pi r. Now the diameter is 8 and so r is 4. So volume is pi times 4 square times the perpendicular distance of 5. So this is the volume. So put all of this in a calculator and you get your volume. So 4 square times 5 times 3.14, I get 251.2 meter cube. All right, nice and easy. Now part 2 says if the area of the base of A, so the area of the base of A is 314 meters square, calculate the length of the radius of tank A. So for tank A, all right, so the area of the base of A, so right, area of A, so this is a subscript A, area is pi r square. This is pi, and instead of saying r, I'm gonna write RA square, which means the radius of tank A square, and that's equal to 314. So if this is equal to 314, we want to find r. We divide by pi first. So 314 divided by 3.14. So that's going to give us that RA square is equal to 314 divided by 3.14. That's 100. And so what does that mean then? It means that RA is equal to 10. R is equal to 10, and that's 10 meters. Now it says tank A holds 8 times as much water as tank B. So it's telling us that the volume, of tank A is 8 times the volume as tank B. Calculate the perpendicular height of tank A. Now, as we saw, volume is equal to cross-sectional area times height. The cross-sectional area for A, as we saw, is 314 times the cross-sectional times the perpendicular height would be, let's call it HA, which means the height of tank A. And that's, of course, equal to 8 times the volume of B. What did we say was the volume of B? The volume of B we found was 251.2. So this is just 8 times 251.2. Nice. So all we're required to do now is, let's work those out now. So that means the HA is really equal to 8 times 251.2, 8 times 251.2, which is 2009.6 divided by 314. We'll divide it, we're going to get 6.4 meters. All right, so that's it. So the height of tank A is 6.4 meters. All right, part B. Part B says the diagram below shows triangles PQR and its image. Triangle P prime, Q prime, R prime, after an enlargement centered at the point C on the diagram. Now it says use information from the diagram to complete the statement below. The size of the scale factor is to determine the size of the scale factor, we can take any side. Let's say QR and let's say R prime, Q prime. R prime, Q prime, this length is 1, 2, 3, 4, and this length is 2. Distance of the image over the object give you the scale factor. The size of the scale factor is then 4 over 2, and 4 over 2 is -2. But since they said size and they didn't really ask for magnitude, you could just put 2. So the scale factor is just -2. Then they ask you, why is the scale factor negative? The scale factor is negative, as you can see, is because the object, the image comes after. The object is in front of the center of enlargement, all right? Usually, when it's positive, what's gonna happen is this. Usually when it's positive, let's say you have a triangle here as the object, then probably the image is here, all right? And the center of enlargement is somewhere here, all right? But as you can see this time, the center of enlargement comes before the object, all right? And so this is a clear indication that the scale factor is negative. Another reason why the scale factor is negative is because the object and the image, you notice that the orientations are opposite. One upside down and one is right side up. So clearly scale factor is negative. So you can say the orientation of the image is the orientation of the image and the object is different, comma, one is upside down and one is right-sided up. So clearly the scale factor is negative. Another means of looking at it, as we said, is that also the center of enlargement is after the image, yes. Well, after the object, sorry, after the object. The center of enlargement is after the object. So that's another reason why, of course, it is like this. Nice and easy, soft. It says the length PQ is 13 units square. Therefore, what's the length of P prime, Q prime? The length of PQ, the length of PQ is 30, root 13. So it gives us this length, the length of PQ. It says the length of PQ is root 13, all right? We already knew this from Pythagoras theorem, because look at this. This side is 1, 2, 3, and this side is 2. 3 square plus 2 square, square root to give you the hypotenuse. All right. And I guess they're going to ask us for P prime, Q prime. We know that P prime, Q prime is 2 times this distance. All right. And so this is 2 root 13. Even without working it out, it's 2 times the square root of 13. So it asks us the length of P prime, Q prime. You can just tell them that it's 2 root 13. All right, because it's 2 times the distance of PQ. Why? Remember the scale factor. It's been multiplied by 2, negative 2. Then it asks for the area of triangle PQR. The area of triangle PQR, remember, it's a half base times height. So it's going to be a half the base, 2 times the height of 3. And so the area is going to be 3 square units. So this should be 3. Then it said the area of P prime, Q prime, R prime is going to be 4 times the area of triangle PQR, which is 4 times 3, which is 12. All right, and you're asking me, so you're going to say, sir, how do you know that this is 12? Now, this is clearly going to be 12 because there's a formula that tells us that area of the image is equal to k squared times the area of the object. Area of image is k squared times the area of the object. This formula, nice, must remember. So area of the image, if the area of this is 3 and k is negative 2, negative 2 squared is 4, then 4 times 3 is 12. So the area of the image is 12. All right, using this formula. So this is the formula that we used. So k squared, as you can see, 2 squared is 4, and 4 times 3, that will give you the area of the image, and the area of the image will be 12. Just to write it down right there. Nice and easy, soft, almost boring. And that takes care of this question. Too easy.